Hi everyone. Today we'll discuss Cauchy root test or Cauchy radical test or simply radical test. So what the statement says, if sigma un is a positive term series and limit n tends to infinity un whole to the power of 1 by n equal to L, then the series is convergent. The series is convergent if L is less than 1. Series is divergent if L is greater than 1. Test fail if L equal to 1, the limit equal to 1. So this is the given state. So limit n tends to infinity un whole to the power of 1 by n equal to L. We are finding this. Whatever the answer we get, according to that answer, we are proceeding. That means L is less than 1 convergent, greater than 1 divergent, equal to 1, test fails. If test fails, we have to go for the another test. We can't say test fails. Then you have to take L equal to 1 and the limit. Then we will proceed. We'll discuss in other classes. Now today we'll discuss only the Cauchy test. Okay. Let's go. We will see the problems. It will be clear for us. So now the first problem. Limit 2 to the power of n by n cube. We have to find. So solution, let un equal to 2 to the power of n by n cube. Now un to the power of 1 by n. Un to the power of 1 by n. So if you take 1 by n, this will be 1 by n. This will be 1 by n whole cube. Now apply the limit n tends to infinity. Un whole to the power of 1 by n equal to limit n tends to infinity. This is n getting cancelled, numerator and denominator. Now limit n tends to infinity and 2 to the n to the power of 1 by n whole cube. As n tends to infinity, n to the nth root of n, you see, limit n tends to infinity, nth root of n equal to 1. So this is 1. 1 raised to any number is 1. So 2 by 1 is 2. 2 is greater than 1. So therefore, the given series un is what? Greater than 1 means what? Divergent. Series is divergent. Divergent. The series is divergent. One more example. Suppose n by n plus 1 whole to the power of n square, or this can be 1 plus 1 by n whole to the power of minus n square. Now let un equal to n by n plus 1 whole to the power of n square. N square means n into n. Now what I am doing, raising both the side 1 by n. This is getting cancelled. So now apply the limit n tends to infinity. Un whole to the power of 1 by n equal to limit n tends to infinity. N by n plus 1 whole to the power of n. This I can write is limit n tends to infinity. N plus 1 by n whole to the power of minus. This is I am flipping. You see a by b is there, I am flipping, writing b by a equal to b by a whole inverse. So minus 1 into n is n. Now this will become limit n tends to infinity 1 plus 1 by n whole to the power of n minus 1 by n. Limit n tends to infinity 1 plus 1 by n whole to the power of n is e. e to the power of minus 1. E to the power of minus 1 is 1 by e. 1 by e is less than 1. Therefore, the given series un is less than 1 means convergent. How can you say? By Cauchy root test. But CRT, Cauchy root test. One more example. Example. Suppose nx by n plus 1 whole to the power of n. Whole to the power of n. So, un equal to n by n plus 1 whole to the power of n. So, raising to the whole to the power of 1 by n whole to the power of n getting cancels. Un whole to the power of 1 by n equal to dividing numerator and denominator by n. So, x 1 plus 1 by n. Now, apply the limit n tends to infinity. As n tends to infinity, 1 by n tends to 0. Answer is only x is there. If x is less than 1, convergent. If x is greater than 1, the series is divergent. If x equal to 1, Cauchy root test fails. Equal to 1, test fails. If 1, test fails. One more example, small example. Summation x to the power of n by n to the power of n. So limit, before limit, un equal to x to the power of n by n to the power of n. Now apply 1 to the power of n. X to the power of n, 1 by n, and this is n to the power of n into 1 by n. Already n is there. So this n, this n, this n, this n, or we can write like this, x by n whole to the power of n. So this is very easy. Why we will go this way? So it is x by n whole to the power of n, raising whole to the power of 1 by n both the sides. So it get cancels. Now limit n tends to infinity un whole to the power of 1 by n equal to limit n tends to infinity 1 by n. As n tends to infinity, 1 by n tends to 0. 0 into any fixed number is 0. And 0 is less than 1. Less than 1 means the summation, the un is convergent. How can you say convergent? By Cauchy root test. By Cauchy root test. One more problem. Problem number 5. 2 square by 1 square minus 2 by 1 whole to the power of minus 1 plus 3 cube by 2 cube minus 3 minus 2 whole to the power of minus 1 plus 4 to the power of 4 by 3 to the power of 4 minus 4 by 3 whole inverse plus minus, it is going on and on. So here what is our un? Un equal to n plus 1 by n whole to the power of n plus 1 minus n plus 1 by n whole to the power of minus n. It is there with us. Now un whole to the power of 1 by n equal to this we can write 1 plus 1 plus 1 by n whole to the power of n plus 1 minus 1 plus 1 by n whole to the power of minus n. So what we are doing? Raising both the side to 1 by raising both the side to the power of 1 by n. So this is 1 by n Here also if you raise to the power of 1 by n, numerator and denominator getting cancelled. So un whole to the power of 1 by n equal to, this can be written as 1 plus 1 by n into 1 plus 1 by n whole to the power of n minus 1 plus 1 by n whole to the power of minus 1. Minus 1. Now apply the limit. Limit n tends to infinity. Limit n tends to infinity. Limit n tends to infinity. So limit n tends to infinity. You see, as n tends to infinity, 1 by n tends to 0. 1 plus 1 by n whole to the power of n is e. This is e. So this is 1 into e minus what is this? Is 1 whole to the power of minus 1. So e minus 1. E is 2 point something, 2 point minus, this is less than 1. Less than 1 means the given series is convergent. Therefore, un is convergent. How can you say convergent? By Cauchy root test, because we are doing all the problems based on Cauchy root test only. That's it. So what we have done? We have done Cauchy root test. What the Cauchy root test statement says? Limit n says to infinity un whole to the power of 1 by n equal to whatever the answer you get. If that answer is less than 1, convergent. So series is convergent. Greater than 1, divergent. Equal to 1, test fail. We have discussed all the three types. Convergent we have discussed. Divergent we have discussed. We got x. Suppose what is x? If x is less than 1, we don't know x. In one problem we got x. You see this problem. This problem. This problem we got. X is, see here. X is less than 1, the series is convergent. X is greater than 1, the series is divergent. When x equal to 1, the test fails. So all the condition we have done. So thanks for watching. I am making videos for every test, different video. Cauchy root test, integral test, all other will be one different videos. Okay. Please do subscribe my channel for more upcoming video. Thanks for watching.